All right, let's look at some more examples. And working with, these are called rational exponents. Now, why are they called rational exponents? Well, rational numbers are numbers that can be represented in fractions. So rational exponents just means I have fractions in the exponents. All the rules stay the same. If I'm multiplying two things, they have the same base, then I'm going to add my exponents. So I'm going to take 1/2 plus 1/4. Now remember, you want to find common denominators. So that's 2/4 plus 1/4. That's 5 to the 3/4. Everything works just like your other rules of exponents. So let's take one of the rules. This one is the rule of product to a power. Now the reason I'm using that rule here is because the bases are not the same. I can't multiply those together. But what I can do is, since we have a product all squared, that really means that I have 8 to the 1/2 squared and 5 to the 1/3 squared. Power to a power, 2 in the sky you multiply, that's going to give me 8. And this is going to give me times 5 to the 2/3. Let's get a little bit crazier. 2 to the 4th times 3 to the 4th to the negative 1/4. Again, these bases don't match, but since it's a product to a power up here, I can apply it to both. That's going to give me 2 to the 4th to the negative 1/4 and 3 to the 4th to the negative 1/4. Power to a power, 4 times negative 1/4 is going to give me 2 to the negative 1. Well, that's going to give me 3 to the negative 1. Remember what the negative exponents mean. That means I've got 1/2 and 1/3, which give me 1/6. Now, could I have kind of used that rule about the product of a power backwards and realized that these were both to the 4th power? So that could have been 6 to the 4th to the negative 1/4, or 6 to the negative 1, and still gotten to 1/6? I could have, but I just didn't happen to see it that way at the moment. Next one. I've got 7 to the 2/3 divided by 7 to the 3/4. Now remember our division. When we're dividing two things and they're the same base, we're going to subtract our exponents. So I'm going to take 2/3 minus 3/4. So we need to have that common denominator to subtract fractions. So let's use 12. Okay? So if I'm going to use 12, I need to multiply the numerator and denominator by 4. That's 8/12. Numerator and denominator by 3. That's 9/12. 8/12 minus 9/12 is going to give me 7 to the negative 1/12, or 1 over 7 to the 1/12. Now, I do want to remind you, what does that mean? That 12 in that denominator. Well, that's the 12th root of 7. But it's a little bit easier to work with as a fraction. All right, what about a little bit more complicated? What if we have a lot of stuff going on? Are our rules really going to change? No. We still work with everything like we used to. So I would take a moment and look at my numbers. I got 6 and 2, both divisible by 2, so that would give me a 3, and that'd be just 1. Let's see, negative exponents. Negative exponent moves to the top and becomes positive. This x by itself, that's really just a 1, right? Okay. Now, or could I write it as 3/3? Would that be okay? I have 3/3 up here, 1/3 up here. 3/3 minus 1/3 leaves me with x to the 2/3. And there's a 3 up there as well. Y to the half, there's nothing below. And there's nothing left in the denominator. That worked out pretty nicely. So all of your rules of exponents work the same way. We're just working with fractions, and that's where it's going to run into problems. A lot of you have trouble with fractions. But don't be scared of them. They're just numbers.